In 1970, making a video game meant feeding a room-sized computer a stack of punched cards and hoping you didn't drop them on the way to the machine, because dropping the deck meant hours spent putting hundreds of cards back in the exact right order. Today, someone can type a sentence into an AI and watch a playable game appear in minutes. Same goal, coding a game, 6 decades apart. What actually happened in between is one of the strangest stories in technology, and almost none of it looks like what people picture when they hear the word programmer. Start at the beginning, the 1940s and 50s. There was no coding in any sense we'd recognize. Early machines like ENIAC didn't run programs so much as get physically rewired for each new task, technicians moving cables and setting switches by hand to change what the computer did. Later machines moved to punched cards and paper tape, a small mountain of stiff paper where a single misplaced hole could cost a programmer days of rework, because there was no screen, no undo, no compiler yelling at you. You just fed the deck in, waited in line for your turn on a machine that cost more than a house, and found out hours or days later whether it worked. Nobody was making games yet. These machines were built for artillery tables and nuclear calculations. They were barely making math work, let alone entertainment. Then came the 1960s, and with it, the first real games. In 1962, a group of MIT students led by Steve Russell got access to a PDP-1, a machine that, for the era, was almost playful, with a round display as a screen instead of a wall of blinking lights. They wrote Space War directly in assembly language, the raw numeric instructions a specific processor understands and nothing else. There was no game engine. There was no reusable code at all. If you wanted your game on a different machine, you rewrote it from scratch, because assembly for one computer meant nothing to another. Every game was a one-off, handcrafted for a single machine that maybe a few dozen people on Earth had access to, running in the after-hours downtime of university labs that were never meant to be used for fun. By the early 1970s, games started spreading a little further, but only among people who already had access to a university or corporate mainframe. Text-based games like Star Trek and later Colossal Cave Adventure ran on institutional computers, written in early languages like Fortran and BASIC, passed around on tape between labs the way people would later pass around pirated software. You still needed institutional access to touch a computer at all. That gate didn't fully open until the hardware got small enough to sit on a desk. The home computer boom of the late 1970s and 1980s changed who got to make games at all. Machines like the Commodore 64, the Apple Roman II, and the Sinclair ZX Spectrum shipped with BASIC built in, and suddenly a kid with a television set and a cassette tape drive could write and run their own program. Magazines printed full game listings you typed in by hand, line by line, hoping you hadn't made a typo 300 lines back. At the same time, arcade and console developers were doing the opposite, writing in raw assembly to squeeze every last drop of performance out of chips with only a few kilobytes of memory, hand-placing bytes to make Pac-Man's Ghost behave or to fit an entire game onto an Atari 2600 cartridge. Coding a game was still brutally close to the metal in both worlds, but for the first time, one of those worlds didn't require a university's mainframe to enter. The 1990s brought C and C++, and with them, ID Software's Doom in 1993, one of the most influential pieces of game code ever written. Before Doom, programmer John Carmack and his team had already proven the model with Wolfenstein 3D. Doom pushed it further. It separated the game's logic from its rendering engine, and it split the level data into separate files, called WAD files, away from the code that drew everything on screen. Fans immediately started swapping in their own WAD files to build entirely new games on Doom's engine, without touching a line of the original source. That idea, build a reusable system instead of one disposable program, is the seed that every modern engine grew from. ID Software then went a step further and started licensing the engine to other studios, turning the code itself into a product separate from any one game. Coding a game was no longer about wiring one machine. It was about building and selling a toolkit. That toolkit business exploded in the 2000s. Engines like Unreal and the newly founded Unity started doing the unglamorous heavy lifting, physics, rendering, input handling, so developers could focus on the actual game instead of reinventing a 3D pipeline from scratch every time. In parallel, a completely different, scrappier scene was growing in web browsers, where Adobe Flash and its ActionScript language let anyone with a free tool post a game straight to a site like Newgrounds. No publisher, no install, no budget required. Two very different paths, one expensive and professional, one free and chaotic, were both quietly proving the same point. Coding still mattered enormously, but a huge share of what used to take a specialized team now came pre-built, and the number of people who could realistically finish a game was multiplying fast. The 2008 launch of the Apple App Store added a third pass. Suddenly, a single developer, writing in Objective-C or Java with a comparatively tiny toolkit, could put a simple game in front of hundreds of millions of phones. Angry Birds and Flappy Bird didn't need cutting-edge engines or teams of engineers. They needed a simple, well-tuned game loop and a distribution platform that did the rest. Coding got simpler for this category of game at the exact moment the potential audience got bigger than anything the arcade or console era had ever offered. All three of those paths, powerful engines, free web tools, and app stores, fed into the same result by the 2010s, one person, alone, shipping a hit game. Marcus Persson built Minecraft's first version by himself in Java. Eric Barone spent 4.5 years solo coding Stardew Valley. Toby Fox built Undertale largely alone using GameMaker, a tool that let him skip writing a rendering engine entirely and focus on the parts only he could make. Not because coding got easier in some magical sense, but because engines, asset stores, and online tutorials had absorbed so much of the foundational work that one determined person with a laptop could now do what used to take a studio and mainframe. Which brings us to now. AI tools can generate working game code, entire levels, even art and sound, from a plain language description, compressing tasks that used to take a junior programmer a week into a conversation that takes minutes. The debate over what that means for game developers is loud and ongoing, but the historical pattern underneath it is not new. Every leap in this story, wiring to punch cards to assembly, assembly to basic to C to engines, engines to AI, did the same thing. It moved the boring, repetitive part of coding a game further away from the human, and left more of the creative part behind. 50 years ago, making a simple game took a room full of engineers, a machine worth more than a house, and months of raw machine instructions. Today, it can take one person, a laptop, and an afternoon. The tools changed almost beyond recognition, over and over, in ways nobody at MIT in 1962 could have predicted. What didn't change, through every single one of those tools, is the thing they were all built to protect: someone, somewhere, with an idea for a game worth making.